Hey guys, I'm back. Now we're gonna go through what the circuit we just created does. We're gonna go to the science behind it, the electronics of why it works, and how we use the science to the electronics. And we're gonna basically also write the code to make the whole complete program. And I'm gonna take you back to the video, and we're gonna see how it works in real life. So okay, let's get started. So the first thing I'm going to do is explain the science behind it, since it's one of the most important parts of this sensor. Alright, so here I made two diagrams, relatively simple. They help explain the science relatively easily. Okay, so let's start. Basically, the difference between these two diagrams is the way the light is reflected from the LED and the coarseness or the different type of material used here. You can see the LED and the LDR. This is two parts of the circuit she created. I've negated the rest of it because they're not necessary. So what I've done is, what we can see here is that in this is a smooth surface. So let's start with that because it's easier to explain. What happens is the light from the LED goes and hits and reflects off the smooth wall or the smooth surface and reflects at nearly the same angle which it hits the wall, and reflects back and goes into the LDR, and the LDR notes this intensity of light. So I've shown three rays of light. As you can see, all these three rays of light hit the LDR at the same and basically what happens is the angle at which it comes in and hits the smooth surface is the same angle at which the reflected ray comes off the surface and hits the LDR. So basically what we get is a high intensity of light because there's no diffraction or there's no spread of light, and nearly all the light which is reflected, which is sent out by the LED, emitted by the LED, is absorbed by the LDR. This is called specularity, this phenomenon of reflection of light, nearly all the light reflecting back the way it comes out, is called specularity. The white thing you see on the apple, that too is an evidence of specularity. So now we're going to the coarse surface. Basically, coarse surface displays something called diffuse reflection. What happens is, as you can see, the three rays of light, they start off in the same angle, same direction. But what happens here is that when the light hits this plane or this coarse, rough plane, the light spreads or it diffuses in different directions. So as you can see, this one ray here comes out above the LDR. This ray goes into the LDR, and this one goes some other tangential direction. This is because the coarseness of the surface. Because of the coarseness of the surface, the plane is not flat, and the angles at which the light rays come off it are weird due to the unevenness of the surface. Basically, this red kind of like transparent sphere shows like the range at which all the light will come off it, while in the smooth surface model, nearly all of it is absorbed by the LDR. The intensity of light shining on the LDR here on the coarse surface is considerably less. This decrease in intensity on the rough surface is what we're going to be using to measure the roughness or coarsity of the ground. Alright, so now let's go to the electronics and I'll start explaining that. We'll start with the schematic and then we'll move on to the PCB. So basically, as you can see here, here's the Arduino which we used. You could use any microcontroller, but I use the Arduino because it's really, I recommend you use it because it's got like lots of you can do a lot with it basically. So here, let's start. The 5 volt is obviously connected to the 5 volt rail. The ground is to the ground rail. Okay, so now we have a digital 12 pin which you connect the LED to. This is the first part of the circuit, or the light emitting part of the circuit. The digital 12 pin can have two modes: yes, no, on, off, high, low, basically binary 0, 1. What happens is when we send it the command, when the microcontroller sends it a command to go high, it goes to 5 volts or the base current, which is 5 volts, and when it tells to go low, it goes to 0, ground, whatever ground is here. The problem with this is the LED cannot handle 5 volts because it's got a really low resistance, and what happens is if there's too much current, then it'll blow up, or the longevity of the LED will be greatly reduced. So we use a resistor in series with the LED to limit the amount of current that is going to the LED to ensure that it doesn't blow up. Yeah. So basically that's the first part of the circuit, the light emitting part of the circuit. Now let's go on to the second part. This part is a little more intense, so I'm gonna go more slowly in this one. So okay, the 5 volt, what happens is the current passes to the 5 volt line, it goes to this, goes to the potentiometer, goes to this connecting wire, and goes to the LDR and goes to ground. However, we can see like this little dot and follow this line across this whole page, and we can see that it goes to the analog pin 0. I'll be explaining that. What happens basically is that a resistor kind of eats up. You can think of it like a resistor is going to eat up part of the voltage. However, the voltage between this, the 5 volt rail, and the ground is always 5 volts, but the degree of how much voltage is eaten by each resistor varies. So basically what happens is the ratio of the resistance of the P1 or resistance of the potentiometer and the ratio between that and the LDR, the resistance of the LDR, is what creates a voltage difference between here. So say suppose if we have this is 10k and this is 10k, so the potentiometer will eat up 2.5 volts, and the LDR will also eat up 2.5 volts, and as a result we get 0 volts. So what happens is 5 volts, there's a 5 volt difference between the ground and this again. However, however it's a little bit more different, like if this is 1k and then this is 1k and this is like 4k, then what will happen will be more voltage will pass through this, so you will get something like 4 volts here and then 0 volts, because this is a high resistance and this will eat up more of the current. So what happens is we take this wire analog. The analog basically takes the input and it'll show a value between 0 and 1024 for the input, and basically it takes the voltage between 0 volts and 5 volts and it finds the and basically the voltage here will be a variation of these two. It'll be in between 5 and 0 volts depending on the resistance of the LDR, and that will be passed to the analog controller here, and that can be in turn passed to the Arduino and the microcontroller, which we can use this value to communicate with our data logging program on the computer, and we can see this difference, the difference of the reflection of light. So alright, so that explains, I hope that explains the electronics and the science of part of it. And of course here's the PCB. It's not necessary to create the PCB. As you can see, we created on the breadboard, but I created a PCB because I actually wanted to cover it, and a PCB ensures that like there's no errors of ambient light or anything, because you can like make a cover for it. So here's the PCB design. I'll be adding this. If you want it, you can just ask for it. So yeah, alright, now we can actually go to start programming. So